What's inside Earth? The geological crust is a relatively thin layer, making up only 1% of Earth's volume. The core at Earth's center has two parts, the outer core and the inner core. But have you ever wondered what other planets are made of? All 8 planets in the solar system are unique and built from very different materials. And can what's inside a planet affect what's outside? How about a journey across space? From the Sun all the way to Neptune, the most distant planet in the solar system. Along the way, we'll explore what's inside each celestial body and discover surprising new facts about space. #BrightSide the Sun, we begin our exploration of the Sun, a gigantic sphere of hot gas and plasma. Its core makes up 25% of its radius. Inside the core, gravity creates incredible heat and pressure, causing hydrogen atoms to fuse into helium. The temperature here reaches 15 million C. All that energy travels outward through a zone called the radiative layer. It takes about 170,000 years for this energy to move from the core to the next layer, the convective zone, where hot plasma bubbles rise and burst at the sun's surface. This is where the photosphere, a 483 km thick visible layer, begins. Its temperature is about 500 degrees Celsius, and it contains plasma cells each about 966 kilometers across. At the uppermost region is a thin layer of atmosphere that heats up again to 2 million C. We should probably leave before we melt. Mercury, our first planetary stop, is Mercury, the smallest of the 4 inner planets. It is only 4,800 kilometers across near the equator and is the second densest planet after Earth. Mercury has a huge metallic core, making up nearly 85% of the planet's volume, containing more iron than any other planet. Scientists recently discovered that Mercury may have both an inner solid core and an outer liquid core. Its outer structure contains a rocky mantle and a solid crust only 400 kilometers thick. Because it's tiny and extremely close to the Sun, Mercury cannot hold on to its thin hydrogen-helium atmosphere. The solar wind constantly blows it away. Venus next is Venus, the hottest planet in the solar system, with an average temperature of 465 degrees Celsius, hot enough to melt lead. Surface pressure here equals the pressure 914 meters underwater on Earth. Its core is about 3,900 kilometers wide, comparable to the distance from New York to Los Angeles. Above it is a 1,930 km thick mantle of molten rock. The crust is made mainly of basalt and is only 10 to 20 kilometers thick. The atmosphere is extremely dense, a true nightmare, containing 96% carbon dioxide, 3% nitrogen, and clouds of sulfuric acid. Earth, now we reach our home, the densest planet in the solar system. The core makes up 15% of Earth's volume and has 2 parts. Inner core, a solid sphere of iron and nickel. Radius 1,220 kilometers. Outer core, 2,400 kilometers thick, made of liquid iron and nickel. The boundary between them reaches 60 degrees Celsius, and pressure is 3.3 million times higher than sea level pressure. Surrounding the core is the mantle, about 2,900 kilometers thick, making up 84% of Earth's volume. It contains silicate rocks, rich in iron and magnesium. The crust is very thin, only 1% of Earth's volume. Along with the upper mantle, it forms moving tectonic plates, which shift as fast as your fingernails grow. Mars, time to visit the red planet, the last of the inner rocky planets. Mars has a core made of iron, nickel, and sulfur, about 1,950 to 1,930 kilometers wide. The core is not rotating, which is why Mars has almost no magnetic field, only 0.01% of Earth's. The mantle is made of silicon, oxygen, and minerals. It is softer and thinner than Earth's mantle, only 1,300 to 1,700 kilometers thick. The crust contains basaltic rock, volcanoes, and a layer of fine red dust that gives Mars its color. Jupiter, now we reach the giant of the solar system, Jupiter. It's a gas giant. If it were 80 times more massive, it might have become a small red dwarf star. If you skydived into Jupiter, you would never land. There's no solid ground. Its core may be a molten ball or a solid rock 14 to 18 times heavier than Earth. The temperature at its center reaches 350 degrees Celsius. Jupiter's atmosphere is 90% hydrogen 10% helium. As pressure increases deeper down, hydrogen and helium become liquid, and near the core, they turn into metallic hydrogen, an exotic, electrically conductive liquid. Astronomers define Jupiter's surface at the point where pressure equals Earth's surface pressure, but it is still just gas. Gravity here is much stronger than on Earth. Saturn. Welcome to Saturn, the planet with winds over 1,770 kilometers per hour and magnificent rings. Saturn is made mostly of hydrogen and helium, with some methane, ammonia, and water. It contains more sulfur than Jupiter, giving it a slight orange tint. Like Jupiter, hydrogen becomes liquid deeper down, and eventually metallic hydrogen near the core. Saturn may have a rocky core, surrounded by hydrogen and helium, but with its low density, only 1/8 of Earth's. Even a rocky core could remain liquid under immense pressure. Uranus. Now we see the blue-green world. Uranus, the first of the ice giants. It contains more ice than gas. Its rocky core is about half the mass of Earth. Surrounding the core is a massive icy mantle, making up 80% of the planet. But this ice is not frozen, it's a hot, thick fluid made of water, ammonia, and methane, sometimes called an ammonia-water ocean. The atmosphere is mostly hydrogen and helium, but its blue-green color comes from methane-absorbing red light. Neptune, our final stop. Neptune, the other ice giant, and the windiest planet in the solar system. Its clouds race across the planet at 1,930 kilometers per hour. Neptune's core is solid, made mostly of iron and metals, with 1.2 Earth mass. The temperature reaches 50 degrees Celsius. Astronomers believe that about 7,200 kilometers deep, there may be a layer where diamond crystals rain down. Above the core is a huge, super-hot layer of liquid methane, ammonia, and water, weighing the equivalent of 15 Earths. The atmosphere makes up 5 to 10% of Neptune's mass and extends 20% of the way down to the core. It contains 80% hydrogen, 19% helium, and traces of methane, which gives Neptune its deep blue color. If you learned something new today, don't forget to hit like and share it with your friends. And here are more fascinating videos waiting for you. Just click on the left or right and enjoy. Stay curious with Brightside.